This is where I feel like I'm a genius because I know these perfect squares. Okay, x squared is equal to 96. And now I'm going to go ahead and take the square root of 96. And that's about 9.8. Hey everyone, and welcome to SOH CAH TOA Park, a place where we practice our math survival skills. So today, it's going to be Off Trails Episode 1. We're going to cover math terrain that a lot of my students covered this week that I think is just worth exploring. So we're going to do PreAlgebra Trailhead, we're going to do the Geometry Meadows, we're going to do the Lake Algebra 2, we're also going to do PreCalculus Summit and Mountain Calculus. So again, this is more of a review. This isn't a lesson. This is just looking at different problems that I saw throughout the week that I think are worth exploring. So if you feel like the problems are easy, great. If not, follow along, grab a piece of paper, and let's get started. Okay, so these were some of the problems that I saw this week that I thought were somewhat difficult for a lot of my students. Again, if they're easy for you, great. If they're not, follow along. I would highly encourage you get a piece of paper, get a pencil or a pen if you prefer that, and let's just get started. So this is the PreAlgebra Trailhead. A lot of my students are now doing angle relationships. Hopefully you're doing the same. And in this first particular problem, it looks like they are going over complementary and supplementary angles. And in here, about what we have. Do we have complementary or do we have supplementary angles? If you notice, this is a 90-degree angle. So both of these angles are going to be complementary. Remember, complementary means angles add up to 90. Supplementary means that they add up to 180. So I'm going to go ahead and set my algebra equation. And we're going to go ahead and do 6x plus 4 plus 4x plus 6 is equal to 90. All right, let's go ahead and combine the like terms because we need to solve for x. Going to combine the 6x and the 4x, that's 10x, and then the constants. A lot of people, for some reason, always confuse that, and they want to add, the 6x to the 4 or the 4x to the 6, but you got to remember to just combine those like terms. So I have 10x plus 10 is equal to 90. I need to solve for x, so I'm going to go ahead and isolate that 10. Now, what do? It's being added by 10, so I need to subtract 10 to both sides. Going to get 10x is equal to 80. And now to solve for x, I'm going to go ahead and divide both sides by 10. And I get 8. X is equal to 8. Perfect. Now, a lot of the times they're going to ask you for questions like this. They're going to solve, they're going to ask you to solve for x. You found it. Great. But then some teachers love to kind of throw this little curveball at you, and they want you to find the angles. So we need to go ahead and plug in the 8 into every value of x for those angles. So for the first one, I have 6 times 8 plus 4. If I simplify that, that's 48 plus 4, and that's 52. And the other, 4 times 8 plus 6, that's 32 plus 6, and that's going to be 38. And remember, these angles are supplementary, so if I wanted to check my work, I can go ahead and add the 52 plus the 38 degrees, and I'm hoping that it equals to 90, and sure enough, it does. All right, cool. Let's go on to the next problem. Again, still angle relationships. What do you notice here? You have two different variables. You have one of them has an x, the other one has a y, so we need to start looking at the relationships here. So take a second to look at the types of angles that we have and see how we can create some algebraic expression so that we can solve for either variable. I can already see the vertical angles in the 2x plus 5 and the 3x minus 33. Now, vertical angles, hopefully we remember that vertical angles are going to be the same, or they're going to be congruent. So they're going to be the same. Oh, I noticed my eraser is huge there. Okay, so I'm going to go ahead and set these up and set them equal to each other because they're vertical angles. And now notice you have a 2x on one side, 3x on the other side. We got to combine those things. So I'm going to go ahead and subtract the 2x to the other side. I get 5 equals x minus 33. One last step. Let's add the 33 to the other side, and I'm going to get 38 is equal to x. Perfect. All right. So we found the value of x. Let's go ahead and plug it into the expressions that we have there so that we can have these angles. So I'm just going to plug it into the one on the bottom. Let's go ahead and do 3 times 38 minus 33. I'm just going to use my calculator for that. Honestly, I'm not that smart at math. I just kind of, know the process. All right. That is 81 for that angle. So I'm just going to go ahead and put the 81 here. Now, here's the crazy part. I don't even have to plug it into the other angle because I know since they're vertical, they're going to be the same. So I know that's 81. And in order to solve for the y variable, think about what the relationship is between 81 and that 4y minus 1. They are supplementary. So we're going to go ahead and add them up and set them equal to 180 degrees. So I have 81 plus 4y minus 1 is equal to 180. Combine like terms, so I have 4y plus 80 is equal to 180. I'm going to go ahead and subtract the 80 to the other side. I hope I have enough space. I'm actually going to move my work just a little further up here. So 4y is equal to 100. Last step, 4y equals 100 divided by 4. So y equals 25. Okay, so far I have x equals 38, y equals 25. And again, if you wanted to solve for the other angle, you can just go ahead and plug in the 25 into the 4y minus 1. I'm actually going to go ahead and do that then. Up on top, I'm going to go ahead and do 4 times 25 minus 1, 100 minus 1, 99. Awesome. All right, cool. That's angle relationships for you. Oh, I totally forgot that I set this problem up too. This was like a challenge problem for one of my students, and she was a little bit confused because obviously it looks pretty gnarly. So in order to solve for this, you got to just start this, picking a triangle that we have, any one of them, and solve for those angles, and eventually you're going to start solving for the variables. So for example, going to start with that triangle here on the left. It's a triangle with angle 40 degrees, and then we have the 90. So how do we solve for the missing angle? Think angle relationships. What do angles add up to? That's 180. So technically I could do a 40 plus 90 plus x is equal to 180. Do some math. 130 plus x is equal to 180. Subtract the 130 to the other side. And I'm going to get x is equal to 50. Look at that. We found the value of n. So I'm just going to kind of put that in the picture here. So I have 50 in there. So kind of weird to look at. But notice, all right, we have the 50 degrees. Now, what is the angle directly across from it? Vertical, right? So that's also going to be 50. So we officially found the value of n. All right. And that's actually all you have to do for every single angle or every single triangle here. Honestly, I don't feel like doing this right now. It's going to take a little bit of time, and I really want to start looking at all the other terrains because there's a lot of problems that we want to get through. So this is actually something that you can pause, start, working it on your own, and then let me know what you get in the comments below. Let's go to the next one. Okay. Now with geometry, a lot of my students are now covering SOH CAH TOA and especially law of sines and law of cosines. And that's exactly what we're going to do in a second. If you notice, I kind of already set that problem up. So I'm going to go ahead and erase it right now. Whenever we're solving problems like this, you always want to look at it's a right triangle. Can we use Pythagorean theorem? Well, we have a 10 in one of the sides. But then if you notice, we have two variables. One for the hypotenuse, the other for the other side. We can use Pythagorean theorem. So the next thing that we have to do is going to be SOH CAH TOA. And every time we do that, we're going to focus on one of the angles, which is 51. The 10 is your opposite. Let me go ahead and write that. 10 is your opposite. The x is going to be your adjacent. And of course, the h is your hypotenuse. Just going to put height there. Okay, so we got to think of one of the SOH CAH TOA, sine, cosine, or tangent to solve for the value of one of the variables. Let's go ahead and do, let's do tangent of 51. So I'm going to do tangent of 51. Remember TOA, so that's going to be opposite over adjacent, so that's going to be 10 over x. Ooh, love this problem, and I'm going to tell you why. You have the x as the denominator, and the one mistake that a lot of students do is they do something like 10 over tan of 51 is equal to x, and that's not the case. Okay, and I guarantee that immediately a lot of students probably already started doing that. Don't. Okay, and the reason being is because the x is a denominator. The first thing we have to do is we have to cross multiply. So x times tangent of 51 is equal to 10. And then in order to solve for that x value, I'm going to go ahead and have to divide both sides by tangent of 51. Some people already have like a nice little shortcut. You know, they erase or they skip this particular step. But I would always recommend that if you're still not, comfortable with that step right there, just show that work. All right, and obviously we're going to need a calculator for this, and be very careful. Make sure your calculator is in degree mode. We're going to have 10 divided by tan of 51. It's going to be x equals 8 point, let's go ahead and do 8.1. Found the value of x. Nice. So if I put that back into my picture, I have 8.1 as my adjacent and then the 10 as my opposite. I can technically do SOH CAH TOA, but if you notice now I have two of the sides, so I can go ahead and solve for the other side by using Pythagorean theorem. So I think it'd be kind of, really fun to use both methods here. All right, that's going to be 8.1 squared plus 10 squared is equal to h squared. Let me simplify that. I got 165.61 is equal to h squared. And in order to solve for that h, I need to square both sides. Plug it into my calculator again, and I get 12.86 is equal to h. If I round it to the nearest tenth, because that's what I did for x, it's going to be 12.9 is equal to h. All right, plug it back in to my triangle, and there you go. That is SOH CAH TOA. All right, let's go to the next one. This one's fun. So remember I mentioned we're doing Pythagorean theorem, we were doing SOH CAH TOA, but then what happens when you have a triangle that looks like this? It's not a right triangle, so we have to use law of sines or we have to use law of cosines. Now there's like all these different shortcuts, and one of the big clues here is that if you have a side angle side triangle, meaning the two sides and the angle that is in between those two sides, we're going to be able to use law of cosines. And I know there's like 3 different versions to law of cosines, but honestly, if you recognize one of them, then you can do the other 2. In this case, I'm just going to set this up. I'm going to use the a squared is equal to b squared plus c squared minus 2ab cosine of a. Okay. Notice that technically they don't tell us which was a, b, and c, so I'm just going to decide that the x is going to be my a, and I'm going to decide that the b is going to be 15 and the c is going to be 19. So I'm going to go ahead and plug these values in. So I get x squared equals 15 squared plus 19 squared minus 2 times 19. Whoops. Technically it's 15, but if I rewrote it or if I wrote it wrong, it's not going to matter because multiplication is commutative. Okay. Nice. Let's go ahead and simplify this. 15 squared plus 19 squared. Use my calculator for that. 586 minus 2 times 15 times 19. That's going to be minus 570 cosine of 26. Okay. I wanted to purposely not multiply the cosine times 26 degrees to the 570 yet, because a lot of students are going to make this one mistake. They're going to end up subtracting the 586 from the 570, and they're going to say that their answer is going to be 16 cosine of 26. That is not the case. We got to be very careful with that. The reason being is because the 570 is still being multiplied to the cosine of 26. Can't forget your PEMDAS. We have to multiply that value first. Okay, again, I showed that because that is a common mistake that a lot of people make. So I just wanted to review it so that you catch that whenever you're doing your work and you know that you should not be doing that. Okay, so back to the 570, I'm going to go ahead and multiply that out. 570 times cosine of 26. All right, that was 586. Whoops, 570 times cosine of 26. I wrote my answer wrong. I got like a big number and it was going to be negative. Don't want that. 586 minus 512.3. Okay, I'm going to go ahead and subtract this and already take the square root. So x is equal to the square root of, 73.7, and then x is equal to 8.6. All right, awesome. We found the value of x. Now, normally, they want you to find all the remaining values, the other angles, but we're not going to do that. We're just going to solve for the value of x, okay, because I want to continue to touch on other problems. This one's really fun, okay? I found this online. Shout out to analyzemath.com. We got to find the value of x, but notice that we have like two different triangles that just look a bit weird. So the very first thing that we want to do is we want to solve, every time you have a problem like this, solve for one of the triangles, either the big one or the small one, and then we're going to solve for the other variable. So if you notice, if I look at the small triangle, that's the one with the 10 as my side. I don't know what this value is, but I also know the hypotenuse is 14. So then what I'm going to go ahead and do is I'm going to use Pythagorean theorem to solve for this. I'm going to do 10 squared, looks like a 16. 10 squared plus x squared is equal to 14 squared, 100 plus x squared. This is where I feel like I'm a genius because I know these perfect squares. Okay, x squared is equal to 96. And now I'm going to go ahead and take the square root of 96. And that's about 9.8. All right, that is the missing side. Back in the triangle, notice that I put a 9.8 on there. That's great. And so now I'm going to focus on the bigger triangle. I have the 10 as my side, the hypotenuse is 16, and then I have the 9.8 plus x as the other side. And again, this is still a right triangle, so I'm still going to use Pythagorean theorem, but I'm not going to go ahead and put the 9.8 plus x as the missing side. I'm going to change it, and I'm going to call it a for now. So I have a squared plus 10 squared is equal to 16 squared. And the reason being is because I'm going to find the value of a, which is the entire length, and then I'm just going to subtract 9.8 from it. So this is going to become a squared plus 100 is equal to 256. I know my perfect squares. I'm good. A squared is equal to 156. And then I'm going to go ahead and take the square root of that. And a is equal to 12.5. And again, this is the length of the entire side. I'll circle that here in red. That is the entire side of that triangle. So now all I'm going to do is I'm going to go ahead and have 9.8 plus x equals 12.5. And so in order to solve for x, I'm going to go ahead and subtract 9.8. And you get x is equal to 2.7. Found the value of x. Let's go. All right. Now we had problems very similar to this for a lot of my Algebra 2 students. They're now doing stats, mean, median, mode. But the one thing that a lot of people are getting confused on is how to find the standard deviation. And there's a whole process to it. Notice the big table here that we have to find. And the very first step that we want to do is we want to fill in, some of the information up on top. They're asking for the mean and the number of values that we have. Now, how do we find the mean? At this point, I think everyone should be pretty proficient in that. If not, no worries. This is where we learn it. Remember, we got to add up all the values and then divide by the number of values that we have. So I'm just going to get my calculator. I'm going to add up all the values that we have on top. Okay, I get 610. And how many values do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of them. And nice. When I divide by 10, I get 61. So that is my mean. 61 is my mean. And then I have the number of values, 10. Okay, this one's going to take a while. And honestly, it's tedious. There's all these shortcuts to it. And I believe I have a workbook on this that you can look online, and I'll link it in the description. But it shows you all the tricks. So if you have this calculator, the TI-84, or if you have your TI-30, which is the blue one, that one works too. There's like some shortcuts that I have on there. Look them up, and you'll see that you're going to save a lot of time. All right, so that first table, I'm just going to go ahead and put all the values that they gave me: 22, 99, 102, 33, 57, 75, 100. And then the second column is they're saying, go ahead and take the difference of this value minus the mean. So what they're saying is 22 minus 61. And you're just going to go ahead and do that for every single one. So again, I took the values, subtracted from the mean, and these were the values that I got in the second column. And now the next column, this is why I keep saying that it's, time consuming, but honestly, it helps when we find the standard deviation. But you're going to take the values from the second column, and now you're going to square them. All right. And the whole point, remember, if you're squaring them, for example, for the first one, negative 39 times negative 39, our answer always has to be positive. All right. There you go. Just finished. And again, time consuming, but if you want to know the shortcut on how to utilize this or find this using your calculator, there is a little workshop that I have that you could download. Again, I'll link it in the description below. So now, third column, we're going to go ahead and add all these up, and we are almost done. I get 5,000. Whoops. I get 8,588. And in order to find the standard deviation, you're going to take this value, 8,588. And usually, because we're finding the sample standard deviation, which is a small amount of numbers that we have, is you want to divide by n minus 1. So that's the number of values that we have minus 1. And then at the very end, you take the square root. So this is going to be the square root of 8,588 divided by 9, because remember there were 10, so n minus 1 is going to be 9. I'm going to take the square root all together, and I get 30.9. That is my standard deviation. And I'm curious, do you know what the standard deviation represents? It is the average value that a number is away from the mean. So on average, every value here is like 30.9 away from the mean, which is 61. Okay, so that just tells you, because the standard deviation is pretty high, it's like a big spread. And we can kind of tell from the numbers. I mean, we have 22, and then we have 100, and then 99, 102. They're spread out. All right, that's how you find standard deviation. And now when we go to pre-calculus, a lot of my students are now covering proving identities, and it's just a common issue that a lot of people have. To be honest, the only way you can get better at this is to just continue practicing a lot of these identities. There's plenty of worksheets out there that you can Google, and there's plenty of worksheets that maybe you could even ask your teacher, and I almost guarantee they're going to have a lot for you. If not, Google them. Literally type proving identities, PDF, and you're going to find a lot of worksheets out there. And that's actually how I found a lot of these. I found this from Kudu Software. And whenever you want to, prove the identity, you want to look for the one that looks the most complicated. In this case, it looks like the left side is the most complicated. So I'm going to go ahead and simplify that. And then hopefully I'm going to make it look like the right side. Okay, so if I'm just working with, let me go back to yellow. Sine squared x times tan squared x plus 1. Okay. So a lot of times whenever we're proving these identities, we got to be very clever with our methods. And if you notice, tan squared plus 1 is actually an identity that we can use. This is technically equal to secant squared. X times secant squared. Okay, before I do anything, I'm just going to go ahead and still set this equal to tan x over cotan x. All right. And now keep in mind that secant squared is the same thing as 1 over cosine. So I'm going to go ahead and convert that now. I'm going to have sine squared x times 1 over cosine squared x is equal to tan x over cotangent x. All right, so this becomes sine squared x over cosine squared x. Now, a lot of the times when we're proving identities, you're not supposed to manipulate the right side. Now, I'm not going to really manipulate the right side, but all I'm going to do is just rewrite it so that it looks just like the left side. Again, you're not multiplying, you're not bringing anything to the other side. You're just trying to make sure if what we found, because it looks like we can't really simplify anything else, is in fact what we have on the other side. So on the right side, it looks like we have sine over cosine divided by cosine over sine. And if you recall, whenever we have these types of problems, you have a fraction divided by a fraction. So this is technically sine x over cosine x times sine x over cosine x. And in fact, this is equal to the same thing. So tan x or tan x over cotangent x is the same thing as sine squared x over cosine squared x. So there we go. We proved that identity. Okay, this one's a little tricky, but if you notice, they're both, I would say, both equally confusing. So you can go ahead and choose whichever side you want to simplify. And I'm going to do the right side. So I have tan x plus secant x is equal to 1 plus sine x over cosine x. All right. On the right side, if you notice that we have only one value in the denominator. So it's kind of cool when that happens, because what you can do is you can separate these things. 1 over cosine x plus sine x over cosine x. Look how easy that was, because now hopefully we can recognize that the right side, 1 over cosine is secant, plus sine over cosine is going to be tangent. And we have proven that the right side is equal to the left side. That one was really easy. Really, really easy. All right. And our last problem, we were doing calculus. This is a big method or a big skill that we really have to start learning when it comes to integration, and that is U substitution. Right away, if you notice, if you try to integrate this using power rule, not going to be very successful. I mean, technically, you can multiply those two things in the parentheses, multiply that by themselves, and then multiply it by 5x squared, but it's going to take you a long time. So again, we're going to go ahead and use U substitution, and we're going to make our U equal to x cubed minus 4. And every time we use U substitution, we're going to go ahead and take the derivative. So du equals to 3x squared. The 4 becomes 0, so now we have dx. Now this is where methods are going to vary from class to class. Some students just leave our answer like this. Others, which I prefer, is they start dividing the 3x squared to the other side, because you want to isolate that dx value. So we have du over 3x squared equals dx. All right, and then now let's go ahead and go to our integral. We have integral of 5x squared. We haven't really done anything much to that. But then because we made u equal to x cubed minus 4, I'm going to have u squared times, and then instead of dx, notice that I know that now I can go ahead and write du over 3x squared for that. So du over 3x squared. And this is beautiful because look at this. The x squareds cancel out. One's on top, one's on the bottom. But then we still have the 5 on top and then the 3 on the bottom. So I'm going to go ahead and pull that out of my integral. And now I have 5/3 integral of u squared du. Ooh, look at that. Easy problem to go ahead and integrate this using the power rule. So this is going to become 5/3, and remember the power rule, add 1 to the power, u cubed, divide by the new power. And don't forget your plus c. You cannot forget the plus c. All right, I'm going to go ahead and simplify this by multiplying the 5/3 times the 1/3, and this becomes 5/9. And I'm going to go ahead and already plug in the value of u that I originally made x cubed minus 4 back into the u in my answer. So this is going to become x cubed minus 4, and then again, don't forget your plus c. All right, and that's it. Again, this is not supposed to be a huge lesson when this is just off trails. We are just reviewing things that you are covering in class. If you see that, go ahead and practice some problems. If you see something that you've never seen before, practice that too. I mean, it's good to be exposed to these types of problems. Anyway, I really thank you for coming along with me. If you want to see more math content, follow me on Instagram or TikTok. Until then, I'll see you next week.